All right, in this first section of chapter 6, we're going to start out talking about the graphs of our trig functions. And really, this isn't too bad. If you think about, um, if you look at our unit circle over here on this left circle here, I have the unit circle. All right, and it goes from 0 to all the way to 360 or 5 in radians. It goes from 0 to 2 pi. And what it's doing is it's taking its x value, all right? Its x value, and from that x value, that is our angle, by the way, is plotting its y value. So if you look actually on your unit circle, it gives you ordered pairs on your unit circle, and for the sine, your sine values is that's your y coordinate on your unit circle. So the sine of 0 is 0, and if you watch where this thing will start, um, let's clear that graph and start from 0. But we're going to start from 0. The sine of 0 is 0, so on the xy axis, it's also a 0. If we go over here to 90 degrees, the sine of 90 is 1 if you look at your chart. All right. And again, at 180, sine is 0, and then at 270, sine is -1, and then at 360, sine is 0 again, right? And it keeps on going. These graphs just keep going and going and going and keep repeating that pattern. If you notice right now with just a regular sine graph, notice that each of our main points, 0, 1, -1, and 0, they all occur in 90-degree intervals here, okay? And that's going to be the case. And like right here, say this looks about like 30 degrees. The sine of 30 degrees is 1/2, and so forth. That's where that graph is coming from. So if you look at the circle on the left, it's kind of like how our pitching machine turned circular motion into horizontal motion, linear velocity. It changed angular velocity into linear velocity. So we're going around a circle, and we're taking that circle that's going around, and we're plotting it in a horizontal fashion. So that's the graph of the sine function. Cosine in the same way. If you look at its main points, at 0, cosine is 1. At 90, cosine is 0. At 180, cosine is -1, and so forth, like that, right? Tangent function's the same way. When it's undefined here, you notice how it skips here where it's undefined. That's an asymptote. We know that. Anywhere it's undefined, it's an asymptote. That's the graph of the tangent function. Okay? When we're talking about a period of a graph is talking about how long it takes to repeat itself. So if we look at the sine function, if we start at 0, when does it start repeating itself? When does it get back to its original start point? All right, it makes one period like this. This graph continues to go on, and I can't extend this any farther. But if we were to graph on a regular calculator, it'd look like a sound wave going up and down like this. It'd look like a sound wave going like this. It'd just keep going, right? And so what a period is how long it takes for you to make one complete motion. So I went all the way up to +1, all the way down to -1, and then I'm back at my start. And the same thing with cosine. It has a period of 2 pi or 360 degrees. So I started at 1, went down to -1, got back to 1. For my y values at 2 pi. For tangent's a little different. We'll start at 0, and I'll clear the graph again. Tangent's a little bit different, and actually 0 is a bad one to start at. But here I'm starting at 90 degrees or pi over 2, and then I'm going all the way to 270 before its next asymptote. It has an asymptote at 3 pi over 2 and pi over 2. That's, if I change that to degrees, that's a difference 180 degrees. So this guy's pattern repeats every 180 degrees, all right? And then if we wanted to look at, we also wanted to look at secant, cotangent, and cosecant graphs. Well, all those are the reciprocals of its original graph. So here's the tangent graph right here. All it's going to do is, reciprocal means switch the x and the y values. All right, so now where tangent is equal to 0, cotangent is now undefined. So that's where an asymptote. So this asymptote here will have to be moved where tangent is 0. Now there's going to be an asymptote here for cotangent because we're flipping around. So like in this case, this fraction is, say, 0 over 1. Well, all right, and this fraction right here would be 1 all over 0. And you know anything over 0 is undefined. So when we flip it for cotangent, we flip it around, this becomes 1 all over 0. It becomes undefined like that. All right, so anywhere at 0 for the tangent is going to be undefined for cotangent. And I'll play a little thing here. And this is a little different as far as what the graph looks like as far as 180 and so forth. Normally, our unit circle deals with a radius of 1. This is a radius of 100, so just pretend this 100 is a radius of 1. So there it's going around in its circle, and that is the cotangent graph right there. These down here, these are in radians. 1.57 is pi over 2. Okay. Continuing on in the same sense, or sorry, that was at the tangent function that I just played. That was a tangent function. Yep. And then the cotangent function then is where tangent was 0. Now it's going to be undefined. So tangent was 0 at x equal to 0, and now it's undefined. There's an asymptote here. Same thing with that pi. Tangent was 0. Now there's an asymptote there as well. All right. And it continues to replay it here. And you notice these parts, if you look back at your tangent graph, this is where tangent was undefined, and this is where tangent was undefined. Okay, moving on. Same thing with sine and cosine graph. All right, here's my cosine graph. Now look at where cosine is 0. Anywhere cosine is 0, now that creates a, when we do the reciprocal of it, it creates an asymptote. All right, it creates an asymptote. And what we're doing here now is we're flipping the x and the y values, and it's a reciprocal of it. So here's the secant graph here as well. All right. So here's an example of drawing of the secant function as it's going around, and so forth. Okay. And then the cosecant function is the same thing. It's where sine is 0. We're gonna have an asymptote. So sine is 0 at 0, so there's an asymptote here. Sine is also 0 at 180 or pi, so there's also going to be an asymptote right here. There's an asymptote here as well. Okay, so hopefully these images help give you a better sense of what the sine and cosine tangent graph, if you're ever in doubt, you can always Google them, and they'll definitely tell you. This says use the graph of the sine function to tell when sine is 1. Okay, so let's go back to this graph. It's a little bit better. So when is sine 1? Notice this tick is a 1, by the way. So when is sine 1 was at 90 degrees. And then actually, the sine function keeps on going. And we said it repeats itself every 360 degrees. So it's actually 1 at 90 degrees in every angle that's coterminal with that. So it would be also 360 plus 90, which would be, what, 450? Plus 360 again, plus 360 again. Or it'd go in the negative direction, minus 360. So every angle that's coterminal with 90 degrees would also be this sine would also be 1 using this graph. So what we can write it as is we can write it as sine of 1, sine of theta sine of theta equals 1 at 90 degrees plus 360k, and k just means how many times we go in a full circle. All right. And it could be, maybe we go backwards, so it could be -1, so it could take into account our negative values over here. All right, so that's how we'd write that. Let's clear this here and answer the rest of our questions. The rest of our questions are pretty simple, I think. It says use the cosine function to tell when cosine equals 1. All right, so let's look at the cosine graph. When does cosine equal 1? Well, it equals at 0. And then 360, and then 720, and so forth. So we could write it at 0 plus 360k again, because our period is 360k. Last one, it says, use the function to tell when tangent of theta equals 0. So click on the tangent graph. When does tangent equal 0? Okay, so tangent equals 0 at 0, 180, 360. And remember, I told you tangent and cotangent are the ones that are different. Or actually, tangent are the ones that are different, that has a period of 180 degrees instead of 360 degrees. So every 180 degrees, tangent is 0. So we'd write tangent of theta equals 0 at 0 degrees plus 180k this time. All right. So that's all I have for you, really. Pretty simple section getting you used to the graphs of the trig function. So I hope this helps. We'll see you in class.